It's a best trade-off you can do, however, because what happens if you run too far out and have too much throw is you raise the mechanical gain of the helicopter or on the control loop, and you basically put it in overdrive, meaning you have to lower the control loop on the program side, else you get wobble and all kind of strange stuff. So there is no other option basically than get the program part to work as good as possible, because it will benefit in the end. If you look at the tail servo, for example, let's go down here so we can see it. If I were to move this even further out, I would raise the mechanical gain, and I would have to lower the gyro gain, and even if I do, I get wag at hard stops and stuff like that. It's the same thing with the cyclic. Get the program to work in its optimal range and adjust mechanically, so you will keep the program in that optimal range. Same thing if you get too much mechanical gain, you get that wobble I talked about, but also you overpower or overstress the servos, so you will put extra stress on the servos, and even if the servos is up for it, is your power supply up for it, you will put a lot of more amps. Just when I did my T-Rex 700, I did some testing. It was a different V-bar back then, so the numbers isn't the same today, but I went from 12 amp peaks down to 5 just changing the mechanics so on the servos. So there is a real thing here to actually look out for. I'm gonna talk a little bit about the cyclic ring here and cyclic gain here. That's the two most confusing fields, I guess, for many of you. Cyclic ring is the hard limit. That's what you're gonna use to limit the throw so you don't bind your swoosh. It will never ever go past that one, period. No matter what you put in the cyclic gain, it won't go past it. So if you don't get binding with cyclic ring at 70 like here, there is no danger of ever getting binding. Cyclic gain is a different story. That's the control loop gain or amplifier for the control loop. If you think about if we were to lower this, I think 80, 10 points above cyclic ring. Note this is for 4.0 right now. I cannot guarantee this won't change in a later version, but right now with this type of values we have two rings. If you look at it as a ring, we have two rings that are identical in size. What happens when you raise the control loop amplifier or the cyclic gain? The outer ring will be bigger, but it will never go past the inner ring, which is a cyclic ring. But the thing is, it will, if you put it this way, it will act faster. It will shoot for the target out here, but always stop on the inner ring, meaning it will react faster. You put the control loop in overdrive compared to what it was at a lower value. 100 being optimal. The pop-up here is old text saying 109. 100 is the number we shoot for as the optimal right now. However, if you have like my Aurora, where you have, I am down to 60 for quite a lot of throw, I have to lower this, else you run into problems, like I said. So I start off with 25 or 30% above my cyclic ring, and that is my starting target when I try tweaking out helicopters. What you can do is to go on to Vbar site and actually get all these numbers off your helicopter follow this guide, and when you come down to you have a tool here which allows you to calculate how much cyclic gain you should put in. Good. It also depends a lot of dampers, head speed, blades, servos, stuff like that, how much slop in the control system there is. So there is no 100% correct answer. If you get wobble at hard stops and you don't get away with lowering the gain, then you might be that your cyclic gain is too high and you need to adjust that.